Okay, so we've just developed our formula for arc length, as we discussed in the last video. Arc length, again, is the integral between your two endpoints of the curve of the square root of 1 plus the derivative squared. Okay. So in our problem here, we want to find the distance between these 2 points, 2, 1, and 7, 4, by using the distance formula, and then secondly by using arc length. So the first thing we realize here is, well, first with the distance formula, it's straightforward, we just use it. But when we're going to come to the arc length question in a moment, realize that these two things, if we're finding the distance between them, then they're connected by a straight line, because that's what the distance formula uses. So we're just talking about that straight line that's going to connect those 2 points as our endpoints. So first, let's just review and use the distance formula, because that's pretty straightforward. So the distance formula is the square root of the difference of the x's. So 7 minus 2 quantity squared plus the difference of the y's. 4 minus 1 quantity squared. And then we just simplify. 7 minus 2 is going to be 5 squared, which will be 25. 4 minus 1 is going to be 3 squared, which will be 9. 25 plus 9 is 34. It's the square root of 34, and we cannot simplify that answer. So we're just square root of 34. Okay, so that was with the distance formula. Now, when we come to using the arc length, again, I want you to remember here that when it comes to arc length, we're thinking of these points as being connected by a straight line. So here I have the point 2, 1, the point 7, 4. They're connected by a straight line. So the function that we're dealing with here would actually just be the equation of the line. I may think, oh, great, I got to go through and find the equation of the line. Actually, we can cheat a little bit, because our arc length formula doesn't care about the actual equation. It just cares about the derivative. It just cares about the derivative. So all we need to know is the derivative of the equation of the line. But the derivative of the equation of the line is just the, I'm going to ask you to pause the video and answer the question. Okay, we're back. Hopefully you answered that the derivative for the equation of this line is just the slope of the line. So all we need to know here to do the arc length formula for a straight line is to know the slope of the line. Well, since we have 2 points, we can use the slope formula. And that would just be the difference of the y's, 4 minus 1, over the difference of the x's, 7 minus 2. So our line has slope 3/5. And again, that is my f prime function. That is my f prime function. I don't actually need to go through the trouble of finding the full equation of the line. I just need to know the f prime function, the derivative, the slope of the line, and I need to know the x values. Well, it's going from 2 to 7. So working out arc length now, we would do the integral from 2 to 7 of the square root of 1 plus f prime squared dx. And then we just work this out. That's going to be on the inside there, 1 plus 9 over 25. 9 over 25 is just 34 over 25. And that, of course, is square root of 34 over 5. Okay. So going back to my integral here, I'll have the integral from 2 to 7 of square root of 34 over 5 dx. That will become square root of 34 over 5 square root of 34 over 5 x. evaluate it between 2 and 7. And when you do that, what you'll find is that really we can just factor out the square root of 34 over 5 for the moment. And we're just doing 7 minus 2 is 5. So that will cancel with the 5. So, of course, this gives us the same answer, square root of 34. Square root of 34. Okay. And so we can confirm that, at least for this problem, our arc length does line up with our distance formula and gives us the same answer. So that's kind of a little encouraging that we didn't just blunder here. We didn't just blunder here.